In Activity 6, Primary Colors, students investigate the significance of primary colors. They prove that the light produced by subtractive color mixing can be made up of a range of different colors. Then they create colored light by passing it through color filters, and finally separate colored light by directing it through a prism, discovering a new set of primary colors: cyan, magenta, and yellow. You will need the following materials from the kit: Activity Sheet 6, color filters, flashlights with frosted acetate, paper screens, sheets of white paper, prisms, sheets of cyan and magenta acetate, and 2 reclosable plastic bags. You will also need to provide scissors and a metric ruler. To prepare for the activity, make a copy of Activity Sheet 6 for each student. Cut each sheet of cyan and magenta acetate into 4 10 centimeter by 12.5 centimeter pieces, which will be new color filters. Each team of 2 will need 1 set of 8 color filters, a sheet of white paper, a paper screen, a prism, a ruler, a flashlight, and a pair of scissors. To begin the activity, review additive and subtractive color mixing. In additive color mixing, individual colors of light are mixed and reflected directly into the eye. In subtractive color mixing, light already containing many colors is transmitted onto a combination of different colored filters or pigments, and only some of the original color is perceived by the eye. Ask students, how can you prove that pigments reflect more than one color and that filters allow more than one color of light to pass through them? Encourage answers that involve separating pigments using chromatography or passing colored light through a prism to see whether a spectrum forms. Next, divide the class into teams of 2 and distribute the materials. Give each student a copy of Activity Sheet 6 and have students read the instructions on the activity sheet to familiarize themselves with the setup. Have students cut slits in the folded paper screen. Then guide students to list several colors and combinations of filters and to predict which colors they will see on the screen. When students have finished recording their predictions, darken the room and instruct them to begin experimenting. Make sure that the light passes through both slits in the first screen by angling the flashlight beam down slightly so that the light makes a visible path on the table or desktop. The students will probably need to make numerous adjustments to the position of the flashlight, filters, prism, and paper screens in order to achieve an identifiable color spectrum. When students have finished experimenting, discuss their results with them. Ask, were you able to separate any of the colors of light into more than one color? Which filters produce light that could be separated? Most students should have been able to produce ranges of colors by separating the light that passed through almost any filter. Then ask, what happened when you overlapped filters? Was the range of colors made by overlapping red and blue filters the same as that made by using a violet filter alone? Explain that in general, the range of colors seen when filters are overlapped will be narrower than that seen with a single filter, because more colors are subtracted as more filters are overlapped. The student should realize that very similar colors can result from varying mixtures of light. For example, what we see as violet light can be made of just violet light or a combination of red, blue, and many other colors. Next, ask students, was there any filter that absorbed just red, green, or blue and let almost all the other colors through? The student should have seen that light from the yellow filter separated into red, orange, yellow, and green without any blue or violet, which means that the yellow filter absorbed the blue light. Distribute a cyan and a magenta colored filter to each team. Explain that cyan pigment absorbs red and orange light and looks blue-green in natural light. Magenta absorbs green and yellow and looks reddish-blue in natural light. Ask students, what colors would you expect to see in a spectrum of light shine through a cyan filter? through a magenta filter. What if you overlap a cyan and a magenta filter? They will see that the spectrum of the cyan light is yellow, green, blue, and violet in that order. For magenta, it is blue, violet, red, and orange. Overlapping the filters will result in a deep blue because blue and violet are the only colors of light not absorbed by either the cyan or the magenta. When they have finished, ask students what would happen if you added a yellow filter to the cyan and magenta filters. Students should know that a yellow filter absorbs both blue and violet light, so all light will be absorbed by this combination of 3 filters. Finally, inform students that cyan, magenta, and yellow are a set of primary colors. They can be combined to form any color because each one absorbs only one of the primary colors of light. Point out that cyan and magenta are very similar to the primary colors they have already learned, red and blue. Magenta and red both absorb mainly green and yellow light. Cyan and blue both absorb red and orange light. And yellow is in both sets and absorbs blue and violet light. To conclude the activity, discard the sheets of white paper, store the newly made cyan and magenta filters in plastic bags, collect all the materials, and return them to the kit. For science background, reinforcement activities, curriculum connections, and information about the Delta Science Reader, please consult your DSM Teacher's Guide.